Wave. What is the definition of wave? We start today. Our topic is waves. Wave is a periodic disturbance in the medium. Periodic disturbance in the medium which transfer energy from one point to other, or you can write one place to other also, without transfer of matter. What is this? See, what is wave? Wave is a periodic disturbance in the medium. You need to understand this. It's a periodic disturbance. Okay. It the disturbance or pulse, we can say, will be, it's a periodic. That means assume there is a string fixed at one end. If you generate a pulse, I think you know what is pulse, right? Small pulse, if you generate, the pulse will move forward. We can call this pulse as disturbance also. But what is the property of wave is it's a periodic. The pulses will continuously will come. It's a periodic disturbance in the medium. Medium means string is the medium right now. Medium is the thing where the wave travels. Okay. Which transfer energy. That means when the pulse is moving forward, what is being transferred? Energy. From one point to other point, one point to other point, without transfer of matter, means mass won't be transferred there. That means when wave is moving forward, mass won't move forward. Mass will just vibrate there itself. That's what called as what? Wave. Okay. This is the definition of wave. Just you need to remember, that's it, nothing else. In terms of IIT, I don't need this one much because probability of making a question is very less. Okay. So this is a wave. Wave is a periodic disturbance in the medium which transfer energy from one place to other place without transfer of matter. But we need to learn a lot about classification. Classification of waves. What is this? Sir, what do you mean? Types of waves? Yes. Sir, I know types of waves. There are totally two types of waves. No. No, sir, I know. There are two types of waves. That is transverse and longitudinal. I'll accept it. But try to understand that classification is based on particle vibration. Particle vibration. So, if you look into the particle vibration, the waves can be divided into two. One is transverse. Other one is longitudinal. Transverse and longitudinal. Sir, what are these two? Okay, I'll explain that. I think most of you already know that transverse wave is a wave where the particle vibrate perpendicular to direction of propagation. No one knows this one.
Yes, sir, we know.
It looks like this. The problem with the wave is that you need to know, or you need to have the visualization, because on board, if I teach, I can't move the wave. Now you see how it is moving. Red dots are particles. Sir, what is that black arrow? Black arrow indicates the velocity. See, when the dot goes to, or else do one thing, focus on the red dot which is on the red line. Sir, it is, how can I observe carefully? The particle comes to rest, maximum, zero, maximum again. When displacement is maximum, velocity is zero. When displacement is zero, velocity is maximum. Sir, it is SHM, sir. Yes. Every particle will execute SHM. Of course, this is not the only wave. Many waves are there. I'm taking simplified versions. This is harmonic wave. Okay. This is a transverse wave. So transverse wave, what will be there? In transverse wave, 1 minute, I'll show it to you. This is crust. This is what, tell me? Crust. Where this will be trough. Crust and trough will be there. And distance between two consecutive crusts, you take it here from this point to this point. Or you can take two consecutive trough also. Nothing to worry about it. So crust to crust. Distance is called as lambda. Lambda is nothing but what, tell me? Wavelength. So transverse wave examples: light is there, wave on a string, wave on a string means guitar string is there, now you can take it, vein and all, wave on a string, or all are what, there are many transverse waves, all are transverse waves only. Okay, right. In transverse wave, what will be there? Crust and trough will be there. Crust and trough will be there. Clear? Now, this is transverse. Now we learn longitudinal. Okay. I haven't got the right, what we can say, animation, but I got very good, not right, but very close to very good, I can say. I got it. So yeah, this one is best. Longitudinal. Don't get good misconcept that there are rings, sir. In longitudinal, rings will be there. No. Longitudinal layers will be there. He is taking rings. It's okay. In case of longitudinal, observe the particle vibration will be parallel to the plane of parallel to the wave propagation. Observe here, wave is propagating like this. Yes or no? Now
Yes,
particle also vibrating like this. So if you observe the blue one, the blue that indicates that particle vibration, it's also SHM only, like the previous one. But the oscillation is in the direction of propagation here. In this case, it is perpendicular to propagation of wave. That's a major difference. A transverse wave in which particle will vibrate perpendicular direction of propagation. Longitudinal wave is a wave where particle will vibrate parallel to the direction of propagation. Example, sound. Very famous example, sound. Clear? So in case of longitudinal wave, we have compressions, we have rarefractions, and distance between two consecutive compressions or rarefaction is called as lambda wavelength. So don't think like longitudinal and transverse are completely different. There are many similarities. Okay, all these things we learn. The first classification is based on what? Tell me, particle vibration. Clear? First classification is based on particle vibration. Good. What is the second classification? Second classification based on energy transfer. Energy transfer. Sir, wave will transfer energy, na? Yes. But anyway, let us take that thing. Progressive. Progressive and standing. Progressive wave and standing wave. See, these two waves here, these two waves Both are progressive waves. What is the meaning of progressive wave? A wave in which energy is being transferred from source to the medium. Check it, energy is continuously going forward. But here also, you see, energy is going forward. So in progressive wave, energy will be taken from the source to medium. Example, let us go for progressive waves. Example, you can take sound. Okay, anything, sound, uh, light, you can take. They are progressive, they go forward. And remember, this is, sir, what about longitudinal? This is longitudinal progressive. This is transverse progressive, but both are progressive only. But what about standing wave? Standing wave is a wave where energy transfer won't take place. Sir, if energy is not being transferred, how it is a wave? You'll understand when you see the diagram. Okay. So the standing wave will be like this. This is a wave, standing wave. So don't think this is the complete wave. Actually, only black one, the black color one is there. Na? That's the only standing wave. Sir, what about background low, kind of blue and red? Actually, standing wave will be formed when you have two waves moving in opposite direction, two progressive waves moving in opposite direction. Superimpose, standing wave will come. Right? First of all, feel that only blue color, focus only on the blue one. It's moving forward, right? Now focus on only red one, backwards. So blue one will take the energy forward, red one will bring it backwards. So what happens is that net transfer is 0. And surprisingly, if you look into the resultant will vibrate like this. Check it. And key thing is that there are some points, especially the red dots. Check it at any moment of time. If red is positive, blue is negative. And if red is negative, blue is positive. Always they're opposite to each other. Check it. Always. So one wave says go up. Other wave says go down. Then net will be always 0. The particle will never move. Okay. And if you look into that, surprisingly, there will be one more point. In that, always focus only on that point. See, crust of red, crust of blue, both will meet, or trough and trough. Okay. So, in case of standing wave, instead of compression rarefractions, we have node and antinode will be there. And don't think like this. Distance between two successive nodes is lambda by 2. We'll discuss in detail. Okay. Node and antinodes will be there. There are a lot of differences. We'll discuss that later, but for time being, this is a standing wave. Example. Many are there. Example for standing waves, 1 minute. Wave on string. What? Maybe you can take guitar string. Sir, I have a doubt. Yes, guitar string will generate standing wave. Yes. Sir, it is sound, na? Guitar string will generate sound, but try to understand. If you have a guitar string, if it is vibrating, it is producing standing waves. Okay. Then what about sound? Because of this string vibration in air, the sound will be generated and sound comes to you. Accepted. The sound generated at the guitar string and which is coming to your ear That is progressive wave. That is what, tell me? That is progressive wave, and that is sound wave, or maybe I can say longitudinal wave. But if you look into the string which is vibrating, it is standing wave. Two waves are involved over there. The sound which is being generated because of vibrating string in air is progressive and longitudinal. And the string which is vibrating inside guitar, I don't know whether you can observe it or not. If you observe closely, you can see the string vibrating. It's a transverse standing wave. Okay. So we can divide the waves into two different ways by progressive. Sir, I have a doubt. Standing wave means only transverse, na? No need. No need. You can have longitudinal standing wave also. Bad luck, I haven't got the animation. But you can have what? So if when I speak about standing wave, I have example for only transverse wave. Longitudinal also I got it. Check it. See, the wave is longitudinal. Only one thing I'll recommend that, don't care about this blue color line. Ignore that. If you ignore that, you observe that there is compression, rarefaction, standing wave. The wave is not moving forward. So what the conclusion is that you can have standing waves in transverse as well as longitudinal. Right, good. Then what next? The next thing is based on dimensions. See, we have two different classifications. The third one is based on dimensions. Sir, what is dimension? Dimensions in which the wave will propagate. Easy to deal with. 1D, 1D wave, 2D wave, 3D wave. 1D, 2D, 3D. We have three different types. Sir, what is 1D? The wave which travel only in one direction. Student may ask, sir, let us take guitar string. Yes. Guitar string is 1D or 2D? Only 1D. No, sir. The particle will vibrate perpendicular. Now, the second dimension is involving. See, when you are calculating, when you are deciding 1D, 2D or 3D, we don't care about particle vibration. We care only about wave propagation. So wave will propagate to and fro like this. Right? That is 1D. So example for 1D wave will be wave on a string, wave on a string. Okay, sir, I got it. But what about example for 2D? Anyone can give example for 2D? Surface waves, or some people call it as ripples also.
Yes, sir.
Yeah, just a minute. Or I can say ripples on water. This is 2D. What about 3D? Easy to deal with.
Sound wave.
Sound wave, correct. Sound wave is example for 3D wave. When you speak, it goes to 3D. Good. Okay, fine. Sufficient. We go for the next one. Then is medium. Last one, medium. Sir, what is the classification based on medium? The classification demands that a requirement of medium. Okay, requirement of medium is the most important thing. Requirement of medium. Sir, what is that? See, some waves need medium. The wave which need medium are called as mechanical wave. Mechanical wave. That does means what? Without medium, they can't exist. Forget about propagation, they can't exist. Okay, right? Or else definition is like this. Mechanical waves are the waves which needs matter medium. Matter medium means some mass must be there. Okay. So example, many are there, right? Sound, light, no, 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 no. Light travels in the medium, accepted. Sound travels in air. Light also travels in air. But light doesn't need air. Light can travel through vacuum also. Isn't it? So mechanical wave example is what? Tell me. Sound. Yeah. Wave on a string you can take directly. Yeah. Sir, how? See, if the wave string wave irukadane, you need to have string. And you can take same thing. Surface ripples on water you can take. All these three things you can take as what? Mechanical wave, which needs medium. Non-mechanical waves, which doesn't need medium. What's the meaning of it? If medium is there, then it won't. No. It may travel in medium also, but they don't require medium. Example of this one, non-mechanical, anyone?
Electromagnetic.
Yeah, electromagnetic wave, very good. If you know electromagnetic, good. Otherwise, light we take. For time being, we take light. But in reality, light, ultra, ultraviolet, infrared, microwave, radio wave, gamma radiation, all these things together is called as what? Tell me. Electromagnetic wave. You are right. Light, or if you want, you can take electromagnetic wave. And remember one more thing, in atomic structure, 11th class chemistry, they told that when electron is revolving around the nucleus, diagram null, it's okay. When electron is revolving around nucleus, you can treat electron as a wave. Do you remember? Louis de Broglie hypothesis.
Yes, sir.
Yeah. So now when you treat that electron, when electron is moving, it is like a wave. So this is called as matter waves. That is non-mechanical. Sir, how? See, an electron can travel in vacuum also, right? Electron can travel in vacuum also. When it is traveling, it can be treated as a wave. Okay, it can be treated as wave. So that wave is that one. So finally, if you ask me, sound, what kind of wave it is? It is, first one, transverse or longitudinal? Longitudinal. Longitudinal. Wait. Sound means you can make a standing wave in sound also, na? But anyway, the sound wave that I'm speaking, what I'm speaking, longitudinal, progressive, three-dimensional mechanical wave. Longitudinal, progressive, three-dimensional mechanical wave. Clear? This is what you need to understand. Wave classification. And we need to learn a lot. Waves needs what? Animations. Because waves are the things which are moving. Statically, we can't explain. We have to go for that. Clear? Sir, okay, sir. In case of waves, are there anything which is common? Yes. We need to know few things that will be there. Velocity of a wave. Don't get confused between particle velocity and wave velocity. See, if you look into this, the particle is having zero velocity here. Check it. Feel that zero velocity maximum, zero velocity maximum zero, again maximum zero. So that is velocity of particle, but velocity of wave is velocity with which the crust is moving forward. Don't get confused between velocity of wave and velocity of particle. Velocity of wave, symbol generally we use V, and wavelength. Distance between two consecutive crust or trough, that's lambda, or compression refraction also we can take. Distance between two successive compressions, or distance between two successive rare fractions is wavelength lambda, you need to know. And the frequency, right? Number of oscillation per second nu. Based on these three, we have a very important equation. V is equal to nu lambda. It is applicable everywhere. Sir, can I apply this to light wave? Yes. Sound wave? Yes. Apply anywhere. It will work. Even for electron magnetic wave, also you can take it. V is equal to nu lambda. What you need to learn, that is velocity, sorry, velocity depends on medium. What is this? Velocity depends on medium. Means what? Let us take sound. Okay. If you shout loud or if you whisper, in both cases, although if you shout loud, it will travel long distance, but velocity remains same because medium is same. And next thing, one more thing we can do. Shouting means loudness. One more thing, boy voice and girl voice. Generally, girl voice will be high frequency. Boy voice will be low frequency. That's how it will be generally. So if both of them are speaking, which will travel faster? Both are same. It depends only on the medium. Okay. So although high frequency, low frequency, it will be same. Depends on the medium. That means when the wave travels from one medium to other medium, it will change its velocity 100%. A different medium you need to. Okay. Next thing is that, see, velocity of sound, if you take it, it depends on temperature, what kind of gas it is there, multiple aspects. It's completely dependent on what, tell me, medium aspects, like what are the molar mass of the gas or the medium, like that many are there. V depends on the medium, and if medium changes, V changes. Nu depends on, that means frequency depends on source. Once the source gives energy to the in a form of wave into the medium, let it go through 10 different media after that, but still frequency remains same. Right? So source changed, yeah, frequency will change. So what about lambda? Poor fellow, it depends on both, because if remember, frequency is being changed in the same medium, V constant, frequency is changing up or down, then lambda has to change, right? And similarly the other one also. So V is equal to nu lambda is a very common formula which is applicable for all the waves. Okay. Right. Now, sir, is there any other thing? Actually speaking, there is a kind of big derivation is there, which I'm not going to do it. That is, there is a formula, generalized form of wave equation. Let it be any wave. Let it be any wave. It must follow a rule. Any wave, it must follow a rule. Sir, what is that? See, that's called as differential form. You may not know that. Still, it's okay, fine, doesn't matter. It is okay. That is dou square 1 minute. Sir, what is dou? Dou will be like this. Dou square by dou t square into whatever wave function you have must be equal to v square into dou square f by dou x square. Sir, one me puriyala. Actually, dou is called as partial derivative. Partial derivatives completed in school or somewhere. Partial derivatives.
Little bit they taught last year, sir.
Okay. Okay. What is partial derivative? I'll tell you. Suppose there is a function f is equal to 3x square is there. Now, if I ask you df by dt, sir, tapu, you took wrong, sir. It is x here. It is t here. No. Intentionally took it. So it will be d by dt of 3x square. 3 is a constant. I can take it out. So 3 into dx square by dt. Right. But bad luck. what we can do is that in this case, 3 into dx square by dx into dx by dt we write. Do you remember chain rule? This is what it will be. So dx square by dx is 2x. 2x. 2x into 3, 6x into dx by dt. Like this we do. Okay. So if you have a different variable than the whatever you are differentiating, then you have to find link between them and deal with it. But same thing, dou f by dou t is equal to dou by dou t of 3x square is equal to 0. Sir, why? Because although x is a variable, in the partial derivative, we don't care about any other variable. Any variable you bring into the equation, for me it's constant, that's it. So entire 3x square is constant, no change. This is called as partial derivative. Okay, so leave it. That means you take the wave function, differentiate with time alone, ignore all other things. Differentiate with x, ignore remaining all other variables. Double differentiate. Then you get this form. There must be a constant. The constant is v square. This is the form, this is the form of what we can say, that equation. Clear? This is good. Next, what next? The next thing you need to understand is that this one is very less important. Harmonic wave equation. Harmonic wave equation. Understood? What is this harmonic wave equation? A wave can be represented, or particle vibration can be represented as y is equal to a sine omega t minus kx. Sir, what is this? I'll explain in detail. But for time being, what I'm telling you is that there's a wave. It's a harmonic wave. Why harmonic? You know very well, sine is a harmonic function. So if you represent a wave in terms of sine or cos, both are harmonic functions. That is called as harmonic wave. We will use this one more and more. Okay. And first and foremost thing, the demerit of this is one dimension. It is one dimension. And in our syllabus, only one dimension is there. Two dimension won't come. Next thing. What is the next thing? Tell me. That is, it is harmonic. Wave need not be harmonic, but it's okay, take it. We have only this one. This is the limitation. And this is moving along positive x-axis. Suppose if it is moving on negative x-axis, what to do? Anyone knows this?
Write the opposite symbol for omega and k. Sorry,
Actually,
same symbol for omega and k.
very simple. You replace minus with plus. Omega t plus kx is negative x-axis. Or maybe let us take the arrow perfectly. Negative x-axis. The wave moving. That's what you need to remember. Okay, sir. What else we need to wait? We need to understand A. What is A? SHM you studied, na? Same thing.
Amplitude.
Yeah, amplitude. Right. Then next thing, omega. Omega is equal to 2 pi by t or 2 pi nu, where t is what? Tell me.
Time period.
Time period. Nu is what? Tell me. Frequency. Sir, what about x? X is location of the particle or position of the particle. X is position. What is y? Displacement. Y is displacement. Everything is there with us. Yes, correct. So only one thing K pending. K is equal to 2 pi by lambda. What is lambda? Wavelength. Do one thing. We move this thing here. Good. Sorry, little bit of throat infection. Disturbance will be there. Clear. So amplitude, time period, frequency, position, displacement, wavelength. Sir, I have a doubt. Yes. This is a transverse wave equation. No, longitudinal also. Sir, how come? X and Y perpendicular, na? Now, what is my point is, your logic is correct. I appreciate that. X is the location of the particle from origin. This is X. And Y is the displacement. And displacement keeps on changing with respect to time. Obviously, it will change. So, X, Y. It is transverse only. No. It can be longitudinal also. What is X? Location of the particle. What is Y? Displacement of the particle. But you need to understand one small thing. That is, in this case, in case of longitudinal wave, X and Y are what? Tell me. X and Y are parallel. In case of transverse wave, X and Y are perpendicular. That's the only difference. I repeat. X and Y are parallel in the equation. That's the longitudinal wave. X and Y are perpendicular. It's a transverse wave. Clear? This is harmonic. This is a concept of harmonic waving. Now we need to solve some questions. Okay, we need to solve some questions. Okay, right. Anyway, if you want to understand, you can understand.
Will use equation 1, sir.
1 minute. Question number 1 is IIT JEE question. To explain this, actually, there is a lecture. Okay. The problem with IIT JEE coaching is that continuously if you keep on teaching, student will get irritated. So what we do, we give some questions. So after that we teach. Now what you need to understand is that first thing, X is equal to Y. Y is equal to A sine omega t minus kx. This is the wave equation. Need not be. There are there is no upper limit. Many different types of wave equations. It's not the only one. Okay. Now, what we need to understand in this segment is we start with somewhere remote mathematics. We'll start with what? Tell me? Mathematics. Okay, sir. What we do? See, let us take coordinate system like this. Okay. Right. So let us decrease the length, not required that much. Okay. Sufficient. Yeah. Take it like this. Now, assume there is a function like this. Nalla varla. Yeah, somewhat good. Right. Just a minute. It starts with mathematics. What starts with mathematics? The understanding of wave equation starts from mathematics. Right. Assume there is a function f of x. Okay. Assume there is a function f of x, which will be exactly representing this one. Sir, it is sine, cos. No. It stops there. The wave equation is like this. Okay. So the wave equation, the function, forget about wave. We are discussing about mathematics. The function is f of x. Okay. Now, this f of x, you can do a lot of nonsense by doing some calculation. So let us take y is equal to f of x. If you multiply with 2, do you know what happens? The function will stretch like this. If you multiply with less than 1, it will skew. It will compress kind of thing. Right? Now, you can do a lot of things, not one. If you know that, good. Otherwise, you learn it from somewhere. If you add plus 2, do you know what happens? It will go up. Size won't increase. It will just go up by 2 units. Okay. Now, last thing you need to learn, that's what I need. Suppose if you add plus 2 inside, that means in the function, example, x square plus 4x plus 3. If this is the function, if you want to do f of x plus 2, what to do? Very simple. Very simple. Take that entire function, add plus 2. But if you want to do f of x plus 2, then replace x with x plus 2 whole square. Understood the difference between those two? Okay. So inside the function, add 2 to. So by doing it, what you're going to get, tell me. Do you know what will happen to the function? If you add 2, anyone? It will move towards left by 2 units. Sir, left or right? Left only. Sir, right is positive. Yeah, I know right is positive. But when you add, it moves towards left. Good. Now, if you subtract, what happens? Tell me. It moves forward by 2 units. So, if you want to move it by some distance forward, if you want to move it by some distance d forward, forward means in the x direction, you have to write f of x minus d. Got it? You need to write f of x minus d. Clear? But what is distance? Tell me. If you know velocity of wave, distance is easy to calculate. Tell me what is the distance? Distance is equal to velocity into time. So put this value here. Then y is equal to f of x minus vt. This is the wave function. It need not be harmonic. It can be anything. Anything, it will be like this. Because wave function should depend on x as well as t. Both dependency. Clear? Okay? Right. So instead of d, I write what? Tell me. Because it is being moved towards right. By vt. We can write like this. So now the entire function will come to a distance of vt. Bad luck. 1 minute. Yeah. Entire function will be shifted towards right. So now wave is a function which keeps on shifting towards right. As time goes on, the function will keep on shifting right. Can you feel it? As you allow time to go forward, like 0, 1, 2, 3, 4 seconds like that, the function will slowly shift towards right. Can you feel it with respect to time? That is nothing but wave. So this is a wave equation. Sir, then what you gave, y is equal to a sine omega. Now that's a one special wave where it is harmonic. Okay, if you understand this, then you can solve problem number 1. What is problem number 1 here? Observe. Equation is given. Y is equal to 1 by 1 plus x square at time t is equal to 0, and y is equal to 1 by 1 plus x minus 1 whole square at what? Tell me. T is equal to 2 seconds. Now, if you understood this basic explanation, x must be replaced with x minus vt, right or wrong? It's not required. Let us leave it. Okay. So x must be replaced with x minus vt. When you put x, then it is what? Tell me. Vt value 0. That means if only x is there, that is when time t is equal to 0. So replace x with x minus vt. So what is the vt value? Vt is equal to 1. Of course, t is what? 2 seconds. That implies v is equal to 1 by 2 meter per second. Answer. This is a basic wave equation. Clear?
So can you repeat the last move did you do?
That is time is equal to 2 seconds. Now time taken is 2 seconds.
Yes, sir.
So what I did is that I brought time here. So 1/2.
So not that one, sir. You directly said that PT is equal to 1, right? So that.
Yeah. X minus VT. What is the minus 1? VT is equal to 1.
Okay, sir.
Okay. So this is the first question. Remember, whatever I explain that cannot completely teach you or cannot make you to solve the problems. While solving problem also I teach something. So question number 1 teaches something. Question number 2 will give you some concept I haven't given. Generally student will feel, sir, you gave in the definition. So what is being transmitted in a wave? Sir, energy B. No. Answer is D. Energy and momentum. Energy and momentum. It will transfer both energy and momentum. Just remember that. Let us not discuss too much in that. Time waste. Simply remember, wave transfers energy. Yeah, energy as well as momentum. Okay, right. Now 3 onwards you can continuously solve. Carry on. 3. Give your answer. Third one is easy. You say that, sir. Third is very easy. Yeah, simple concept. A. It's a transverse wave. Fourth one, sound wave does not show the phenomenon of. What is that phenomenon of? Interference? Sir, what is interference? Diffraction? What is diffraction?
B.
Refraction? Yes, sir, I know refraction. 10th class I studied. Polarization? What is polarization? So this question must be asked at the end. But anyway, remember that sound will not show polarization. Sir, how? You can understand this only after completing what? The topic of polarization. It is there in light. Transverse waves can be polarized. Longitudinal cannot be polarized. That's a uh, basic point. So for time being D, sir, I'm not convinced. So don't solve question number 4 because you need a lot of explanation, right? We need to understand what is interference, diffraction, refraction. Refraction, I think you know. Reflection, refraction, basically you know what is for waves. Polarization, you don't know. These 3 we have topics in wave optics. We have interference, we have diffraction, we have polarization. Once we complete, you can understand it in detail. Okay. So question number 5. Answer 5. Now try to understand question number 5. Sir, what is note? Note means, see, when you speak, when I speak, I'll speak at a no. I won't speak at exactly at one frequency. I speak multiple frequencies, but they are very closely packed. That means one range of frequencies I'll speak. Okay. Do you understand? And generally, the dominant frequency is called as note. Note is a word which is used in music. Note is a word which is used in music. Note. Okay. So next thing is octave. When I got this question for the first time, octave. Oct means 8. Suppose initially is 100, assume. Octave means 800. I thought like that. Then it's wrong. It is given as 200. If 100 is the frequency, 100 hertz, units is hertz, and octave is 200 hertz. Octave means into 8. Na? That's what I have a doubt. But in reality, you need to understand this one. This kind of questions, lot will be there in IIT and NEET coaching. Why? Because some university, some board, Kerala board or Tamil Nadu, I don't know it's there or not, but I'm telling you, some board, maybe Madhya Pradesh board or something, they add a topic called as music and sound, or sound and music. That means they feel that we are giving great science. Maybe that they may be true. They discuss about music. See, if you take sound, sa, re, ga, ma, pa, da, ni, sa, everything is flat. I do understand, but will be there. Music, this, that, blah, blah, blah. They gave science. In reality, the students who studying who don't understand core music and all these things, simply they start mugging up the definitions. Okay, and the mother item. So some board or someone
somewhere, or one physics teacher is there. He's great in what? Music. So he want to bring something. So he want to give a creative question. In the music terminology, octave means double. Because I don't know much about it. Sa, re, ga, ma, pa, da, ni, sa. The final sa must be double that of first sa. Right? When you're practicing, you just, and those who go on through Carnatic, they know very well. First sa, final sa must be double the frequency. Double. So if you count it, sa, re, ga, ma, pa, da, ni, sa, it will be eighth one. So octave, they say, but it is double. So, sir, wait a minute. Why all these things? Why I need to learn what to do? It may not be there. It may be there in, I'm not speaking about IIT exam. When you are writing some other practice exams, sometimes suddenly it may pop out. So what will happen is that once this kind of problem pops out, although there is nothing wrong with your knowledge, okay, but you will get -1. Do you understand? So you feel demotivated, but in reality, there is nothing wrong with you, and the question is out of syllabus. Anyway, to avoid that trouble, I'll keep on giving all possible words, terms, and all these things. Note is a term. Sir, what is note? Note is nothing but a frequency. Octave, double. Okay. Octave, double. Okay. Right. So 2 octaves. Again, I have a doubt. Yeah.
If it's 2 octaves, shouldn't it be 4 times the initial value?
How do you know? How do I know? It is music-based question. Right? See, 128, if you take it into 2 will be 256. Definitely 256 will be octave. Okay. Right. Now, 128. Now, the next octave must, okay, I don't know, it is 384 or 512. I don't know that. Sir, what is this? I'm explaining a phenomenon. When you are writing exam, this kind of trouble will come. That, see, it is not in the syllabus. Okay. And maybe, see, you can say, sir, sound means wave. Wave means wave syllabus only. Like that, you can take anything into wave, right or wrong? So that kind of things they do. It will happen in examination. While writing your chapters, phase tests, or somewhere, one question will come, onnume puriyadu. Sir, it is the syllabus le illa. Yes. But they somehow find the relation with what? Tell me. Syllabus. Wait, sound. Sound means wave. Octave, blah, blah, blah. You can't help. You can't fight with them also. So what is my point is, I'm explaining a situation kind of helplessness. You can't argue with them also. So even for me also, I'm telling you, I don't know much about it. I personally feel 512. 512 angilla. What to do? 384 is the only option you have. Mark it and leave. Okay. So answer is D. Sir, if 512 is also there, what to do? Kana, that's what I'm telling you. No one knows here. Summa, they take a very remote concept. Remote concept means like, not like a physics concept. Somewhere it's remote. At different, it's a matter of word. It's not like that you can't calculate what is into 2 or into 8. Octave means it can be into 2 also. It can be 8 into 8 also. Okay. It's not a problem that you can't calculate into 8 or into 4. You need to know what is the exact meaning of octave, which is not in anywhere in NCERT textbook. The trouble you will get. Then what to do? Then my point is very, very simple. You will reach that situation. Okay. Simply smile and leave. Because I don't think in IIT at mains exam that they'll give. I don't think so. In your chapters, it comes, leave it. So what is that? Examiner want to take mark from you by creating question based on a topic which is kind of out of syllabus. And I can't argue with him because, yeah, sound, okay, science, they made. Okay, right. That's what you need to understand. Anyway, we'll start with what? Question number 6. We go ahead with the question number 6. Okay. Question number 6.
Option B, sir.
B. Actually, I'll tell you the methodology to solve this question. Light can travel in vacuum, but not sound, because once you read it, once the cause is being asked, don't read ABCD options. Because if you look into the ABCD options, sometimes not this one, sometimes all options are right or 2 options appears to be correct. So what is my recommendation is that when the cause is being asked, or when you read the question, before going to ABCD options, try to get the answer, logic of answer. Light can travel in vacuum, but not sound, because light is electromagnetic or light is non-mechanical, sound is mechanical. That's the meaning, right? Then go to ABCD options, then try to find out which is suitable. This must be done if assertion reasoning is there. If they make a right question, reason that you feel, yes, correct, always. Whatever reason they gave, you feel correct. Okay. So that's why don't read the reason, read assertion first. And think about possible reasons, because 2-3 reasons may be there. Get all the things, then go to option B. Clear? The option B means like reading the reason. Okay. Let us start. Speed of sound is very much, no. That's not the reason. Light waves are electromagnetic in nature. Yes, light is electromagnet. That explains why light travel, but it won't explain why sound won't travel, right or wrong? Sound waves are electromagnetic, no. Light waves are not, no. So there is no option in this case. Although the answer given is not complete, answer is B only. Sir, don't you think B is also not a right explanation to the question? Can I see? You can't fight with them, right? Out of ABCD, only B is a possible option. Why argument? Mark it and leave. That's it. Okay, right? It happens many times. Okay. Now question number 7. Question number 7. Question number 7. Particle on the trough of a wave at any instant will come to mean position. What is that? Trough. You need to understand this transverse wave. Particle on trough will come down to mean position. It goes to negative extreme, again mean, positive extreme. So one oscillation means time period. Extreme to equilibrium, time period by 4. That's it. So I feel like this is not wave question. It is SHM question. So T by 4, answer is bravo B. Good. 8th one. Solve. Sir, 8th one question purila. I don't know anything about it. I never studied it anywhere. So a distance between two consecutive, sorry. The disk of a siren containing 60 holes rotating at a speed of 360 RPM. RPM means round per minute. What is disk of a siren? Right? You may know, you may not know. Once upon a time when you used to have factories, okay, in case of factory, we used to have a siren there. Okay, right. The siren will have what? Will have holes in it. Okay, so those holes, yeah, like that holes will be there. I can't make all the holes, so I'll make few. A disc with a hole. What they do is that there will lot of holes like this. A circular holes will be there like that. Okay, right. What will be there is that there will be a nozzle through which high sound will come out with high velocity. No. nozzle through which sound will come with very high velocity. When sound is coming with high velocity, when hole comes in, the air will go out. When the disc comes in between, then air will be blocked. So it generates compression rarefactions. This is how they use to produce huge amount of sound. Normal speakers are not sufficient. Normal speakers that you use, it can generate some sound, but to generate huge amount of sounds, you need to have a disc sound like that. Sir, I don't know all these things. You may not know it, but in examination, you have to do a little bit of what? Adjustment. So 360 RPM, 360 RPM, right? So 360 RPM is equal to 360 by 60 RPS. RPS means round per second. So it's how much, tell me? 60. So what is conclusion? It completes 60 rounds in a second, right? Then how many holes are there? 60 holes. That means 60, one complete round will make it to go through 60 holes, right? So one round will give you 60 compressions. 60 rounds will give you how much? 360 compressions and 360 rarefactions. So frequency is 360. So here, what is my point I would like to tell you is that whatever you study, examination is slightly off. Sometimes it's really off. Something like I gave an example, octave. What is nonsense? We don't know that. Completely off, and examiner kind of cheating, I personally feel. Okay, if it is a syllabus, it's a different story. Without that, we can't. Or sometimes the creative question they give, in this case, sir, even this also not explained in syllabus. If at all question has to be given only in the explanation in syllabus, then you can't make the paper. Na? So sometimes what you study is slightly off. You need to use some creative brain to manage things at that moment. Okay, that's all for today. My strong recommendation, you go through the question paper. Next class, solve up to 18 and come. Okay, my 1 minute.
Sir, can you send